Hi, this is Algogo, the exam sorting algorithm. Currently, the exam schedule shown on the KMIT website is shown in the order of subject code. While this might be easy and simple for the administrators to create, it is not so for the teachers and students alike to read. There are also a lot of subjects that do not already have an exam schedule and need to find the time to do an exam outside of the schedule. One of the major problems from this is finding a time where everyone is available. With a properly arranged schedule, finding the time will no longer be difficult. Lastly, the current exam schedule on the KMIT website cannot be easily changed. This will become a problem when a subject no longer requires an exam or the exam date has to be changed for whatever reason. In order to solve all of the aforementioned problems, we decided to create an algorithm which will allow the user to sort the exam schedule in any preferred way, whether it be alphabetically via student's name or course name. Course ID and even date is possible with this Algogo algorithm. Edit or delete examination details however you like. It can even automatically search for duplicates and delete it for you. How this program works is that it will take input from the user. The user needs to input the subject code, subject's name, examination date, examination start time, examination end time, student's name, lecturer's name, and the exam room. The user then can choose to edit or remove data as see fit, while the program automatically search for duplicates and delete if found. The user then chooses how to sort the results, and finally the algorithm will display it as instructed. First, we start by importing pandas and tablet. Pandas will be used to create a data frame which will allow the data to be easily manipulated. Tablet will display the data in a coherent manner. It did this by creating a table made up of symbols around the data from Pandas data frame. As you can see here, the program starts with a dictionary of data being created before being put in a data frame. This is to simulate the existence of pre-existing data in this algorithm. This section of the program shows the insert, edit, and the deletion of data within the data frame. For the insertion of data, all of the data needs to be inputted. This includes the subject code, subject name, examination date, examination start time, examination end time, student's name, lecturer's name, and the exam room. The .loc will define the row in which the data will reside. Next up is edit. What the user needs to specify is only the row and the type of the data that is to be edited, and the new data will automatically replace the old data. As you can see in the slide, the student's name from row 6 is changed from InTouch to Min. Lastly, the deletion of data. This command will delete an entire row of data. The user only needs to specify which row they want to remove. This is the function which will search and remove duplicate data. The searching method is a linear search. This is because it is the simpler search method, and the data being inputted should not be too large. For example, for this subject algorithm, there are only around 60 students. While it might seem like a lot of people for a human to look through, it is nothing for linear search. At the top, the toRemove array is created to store lists that will be removed if a duplicate is found. The algorithm will execute the linear search by finding both the I and j in range of all the data rows. This effectively checks every single row against each other, making sure that there are no duplicates to be left. If a duplicate is found, it will be added to the toRemove array created in the beginning. Lastly, at the bottom, the list inside of the toRemove array will be dropped. Next will be the name of the sorting section. Next will be the name sorting section. The algorithm will sort names in alphabetical order. The problem with sorting words is that they do not have apparent comparable values. Thus, it needs to be operationalized before any sorting can begin. While we acknowledge that Python does come equipped with commands to automatically sort words in alphabetical order, we decided to create our own algorithm in order to explore and learn the process of it. The quantName function is a function that will be used to operationalize letters. The basis of it is to convert letters to ASCII. This will save us the trouble of creating our own dictionary defining the so-called value of each letter. First, the phoneme array is created. The purpose of this array will be explained in just a little bit. Next, next a counter name count is created, and then the loop will be made with I looping through text and the array ASCII will be created. The array ASCII will be used to store each individual letter in the name as an ASCII code. Next up, J will be looping through each individual letter in text at the index count. Text is the collection of names that is inputted into the function, and at each index is the individual name. Then each letter inside of the name at index will be converted into ASCII before being stored in the ASCII array. The if condition right under is to deal with the capital letter at the beginning of name. This is because the ASCII values are different for capitalized and uncapitalized letters. Right now, the integer multi is created with the initial value of 1. The way that this algorithm will sort the alphabet is by assigning total value to each individual name. Names higher up on the alphabet will have lower values, and names lower down on the alphabet will have higher values. Now, humans have no problem sorting the alphabet because even if the first letters are the same, we will simply look at the second letters and so on. To make an algorithm do something similar, all of the letters must have some values attached to them, but the further down the word the letter is, the less important it becomes. This is where the multi-integer comes in. As observed in the code, the ASCII value will divide by 5 to the power of multi. With each iteration of the loop, the value of multi will increase, decreasing the values of ASCII, producing a sense of diminishing importance. Lastly, the value of each letter will be summed up, put into the phoneme, and the process repeats for all the names that were inputted in. This is the typical quick sorting algorithm with the function sortLetter added in to adapt into it. As the name implies, sort letters. In the function sortLetter, the names that were inputted in are passed to the quantName function that we just talked about in the previous slide. The result, phoneme, is stored in QName in this function. Then the low and high are defined with low being 0 and high being the length of the QName array minus 1. Lastly, name, QName, low, and high is passed on to the quicksort function, where normal quicksort operations begin. The quicksort function begins by checking whether there is only one element in the array. If that is true, it will simply output the result without any further work. In most cases, that will not be true, and the process will continue. The algorithm will then check if the value of low is actually lower than high. If it is not, then it means that the number has already gone through the quicksort function and is now sorted. In the first iteration, this condition will always be true. Next, the pivot point pi, or pi, will be defined by running the partition function, which we will discuss in the next slide. In a nutshell, the partition will sort some of the array and return with a new pivot point to be used later. After the partition function is executed, the quicksort function will recurse, calling back its own function, but this time it will be sorting the values to the left and the right of the pivot point until the entire array is sorted.
This is the partition function. It will begin by receiving text ARR low and high from the quicksort function. Text is simply the name to be sorted. ARR low and high are the queue name. Low and high from the previous function respectively. Then it will create a value I which is equal to low minus 1. Next it will create the pivot point using the last element in the ARR array. This pivot point will be used as the main component in sorting the array. The next for loop will begin the actual sorting. It will check all the elements in the array, and if it has a value that is less than a pivot point, it will be moved to the position left of the pivot point. This is where text and ARR work together. The quicksort algorithm will be sorting the ARR array since the ARR is just a the operationalized version of the text array. The text array can be sorted by moving as ARR array moves. In, in hindsight, the pivot point of the partition can be predetermined instead of choosing the last letter because the range of alphabet is already known. This may help to improve the speed of the sorting algorithm, especially for larger datasets. This will be the sort date algorithm. Unlike names that cannot be simply be converted to ASCII, hence a list of months and the number of days in them need to be defined. Next, the date and the month from the input data is split for it to be sorted. This is achieved by running I through every row to check all the dates and character through each character. When a space is found, the date and month is the split away from each other. It is then sorted in a split date list. Since the input is taken in as a string, we need to convert it into an integer. In the previous slide, we store the split date into a list. We can simply just access each variable by simply using the index 0, 1, and 2. We can convert the index 0 and 2, which is just an integer in format of string, by using the int function. However, for the month or index 1 can use that function since it a per string. We can then achieve it by comparing the month name to the list of months that is assigned in the previous slide, and then add 1 to the matches month index since the list is starting from 0. Next, we need to find a way to calculate the day in a year, which can be ranged from 0 to 365. We did it by adding the day from the start of the year to the input month, and then subtract to find the total day passed. For example, the day from the start of the year till March 11 is 69 days. Then we will store this value in the respective row of date in a temporary column. After we obtain the value in the previous slide, we can just use any sorting technique to sort the value. In this algorithm, we will use insertion sort since it's the best runtime is the the best runtime is linear. The algorithm is simple, where it will iterate through every row in the table and then compare to the current value is greater than the next value in the day pass, or the temporary value that we created in the previous slide. If so, it will then swap the row and the process will continue a until all of the values are sorted. This is a time sort algorithm. While keeping the order of the date sort, the algorithm is very similar, but instead of splitting the string on space, this will the split it on column. However, since all the variable of time are taken in as an integer, we can simply join the list together. Then we will store this value in the respective row of the date in a temporary column. For example, if the time is 9 colon 30, the algorithm will convert it to 9:30. This is the this is the insertion sort of the time. We are using the same algorithm as the previous slide when sorting date. However, we modify it to only sort if the date is the same by simply adding an if statement. If we do not see this, if we do not do this, it will just sort according to time. After sorting, we will delete the temporary column since it won't be used anymore. This is simply bubble sort used to store the subject code. Variable I will iterate through all the rows and M will iterate through all the value. If the value to the left is larger than the right, it will switch places. This will continue until the largest value is to the rightmost index. The process will continue until all of the values are sorted. For printing out the output, we simply call the function that we want it to sort, then use tabulate to print the table for us to read easily. Then we will repeat the process again for all the other value that we want to sort. The table at the top shows the result of the initial data without any adjustment done to it, while the bottom table shows the table that had duplicate entry removed. In this slide, the top table is sorted by a subject code. As you can see, the subject code starting with the 1 at the top and the subject code 9 at the bottom. The second graph sorted by date. January, April are at the top and November and December are at the bottom. If there are two exams in the same day, the one with earlier exam is at the top as seen on the December 2nd exam. After those two tables, we have sorting by student name, where we will sort by the name of the student starting from A to Z. Then we will sort by subject name, which is also arranged by A to Z. Lastly, we also thought about how to improve things further. For example, we can make it to get the information or import the information from Excel or CSV directly. Or we can export the output into a file or even put it on website. And thank you for listening.